Do you feel the vibes?
Okay, so first, let's talk about what a rational function is, right? Before we start graphing them. A rational function is when you have a function and you have one function in the numerator, another function in the denominator, okay? To graph a rational function, first you have to find the zeros and the asymptotes, okay? So I have laid everything out here on how to find it. So whatever you're going to do, you're going to refer to this page. So first of all, how do you find the zeros? To find the zeros, you have to set g of x equal to 0 and solve it. G of x is the numerator. So you have to set the numerator equal to 0. You don't even look at the denominator. So for example, suppose you have f of x is equal to 2x plus 5 over x minus 4. If you want to find the 0, you completely ignore the denominator. You just take the numerator and you set it equal to 0. So you say 2x plus 5 equal to 0, 2x equals negative 5, x equals negative 5 over 2. That is the 0 of the function. Okay? Completely ignoring the denominator. Okay. Make sure you write this stuff down. Okay, next, how do we find a vertical asymptote? To find a vertical asymptote, this time you set h of x equal to 0, meaning you set the denominator equal to 0. So in the same example from above, if I have f of x is equal to 2x plus 5 over x minus 4, you know how for the zeros I completely ignored the bottom? Now it's the opposite. I completely ignore the top. I just go into the bottom, set this equal to 0, x equals 4. That's the vertical asymptote. Okay, so in the chapter when we did exponential functions, we had horizontal asymptotes. Now we have both. This one is a vertical asymptote. It's a vertical imaginary dotted line. Okay, lastly, how do we find horizontal asymptotes? Okay, horizontal asymptotes is a different type of process. For horizontal asymptotes, we have to compare the highest exponents from the numerator and the denominator. So this term, the degree just means highest exponent. Okay. So g of x is the top. H of x is the bottom. So if the degree of the top is greater than the degree at the bottom, no horizontal asymptote. If the degree of the top is less than the degree of the bottom, then the horizontal asymptote is y equals 0. If they have equal degrees, then you have to compare the ratios. Okay, so let's do some examples here. All right, so suppose I have f of x equal to x cubed plus 7x over 2x squared plus 5. What's the highest exponent in the top? 3. It's 3, right? Just look at the number, 3. What's the highest exponent in the bottom? 2. Okay, look at this. Oops. 3 and 2. 3 is greater than 2. Top is greater than the bottom. No horizontal asymptote. I'm gonna do all 3 examples right now. Okay. Okay. So yeah, 2x squared plus 5. Just focus on the square. So higher exponent on top, No horizontal asymptote. Now, let's do another example. F of x is equal to x cubed plus 5x over x to the 4 minus 2x. Now, exponent on top is how much? Bottom? Okay. Bigger exponent on the bottom or smaller exponent on top, smaller exponent on top. The horizontal asymptote is y equals 0. That's it. Like, it doesn't matter what the actual numbers are. Bigger on top, no asymptote. Smaller on top, y equals 0. Now, what if they were equal to each other? So f of x is equal to 2x cubed plus 4. F of x is equal to 3x cubed minus, 5. Look at this one. Do you see how they're the same? When they're the same, you take the coefficient and the coefficient and you say 2 over 3. Okay? All right. You have to remember this. You have to memorize and remember this. You are not going to be given this. Okay. Now, let's do this. So here's what it looks like if you have horizontal or vertical asymptotes. So take a look at this one. There is a vertical asymptote here, right? At x equals -1. There is not a horizontal asymptote. Take a look at this one. You have a vertical asymptote here and a vertical asymptote there at x equals -1 and x equals +1. Do you see how this crosses x equals -1? This crosses x equals +1? Those are the vertical asymptotes, right? So for the first one, this point is x equals -1. It crosses through x equals -1. It's a vertical asymptote. Okay, there is also a horizontal asymptote here, right there. Actually, let me do it like this. This is the horizontal asymptote here, okay? What's the y value here when it crosses the y-axis? 0. So the horizontal asymptote is at y equals 0. Okay, so take a look here. This is a vertical asymptote. The vertical asymptote crosses here at x equals 3. So the vertical asymptote is x equals 3. Now, there is also a horizontal asymptote right there. The horizontal asymptote crosses the axis at y equals 3. So the horizontal asymptote is y equals 3. Oh, shoot. Yes, it's 2. You're right. Okay, y equals 2. Now, you cannot just give a number for the asymptote. It has to be x equals a number or y equals a number. I am very consistent about taking points off for those because it's literally mathematically not okay. All right? Okay, so let's graph this. So first, we have to find the zeros. So we go over here. How do you find zeros? You set the numerator equal to 0. Okay, here, the numerator is x plus 2. X plus 2 equal to 0. X equals -2. Okay, so -2. Okay, y-intercept, you have to plug in 0 for x. So it would be y equals 0 plus 2, 0 minus 1. That's 2 over -1. So that's 0 comma -2. Okay? Okay. Vertical asymptote. What did we say to do for the vertical asymptote? We set to, yes, the denominator equal to 0. So let's do that. The denominator here is x minus 1 equal to 0. X equals 1 is the vertical asymptote. Okay. The horizontal asymptote, I have to compare the highest exponent on top and the bottom. The exponent on top is 1. The exponent on the bottom is 1. So I say y equals, if they're the same, you take the coefficients and you set them equal to each other. It's 1x, 1x, 1 over 1. So it's y equals 1. Okay, now, no. The exponents here are the same. That means I need to take the coefficients and set them over to each other. The coefficients, okay? All right, so let's plot what we have so far. X equals -2. The y-intercept is 0 and -2, right? That's the y-intercept. X equals 1 is the vertical asymptote. Here's where you have to be super careful, right? X equals 1. So here's what I do. Go to x equals 1. That's right there. Because I don't want you to get confused between, like to do a vertical or a horizontal line. This is the vertical asymptote. It's got to go up, down. And also it says x equals 1. This is x equals 1, that red dot. So your asymptote, it has to cross that point. If you think about it that way, you will never have it in the wrong orientation. Now let's do the horizontal asymptote. First, it's horizontal. That means it's like it goes left, right. Okay, horizontal. Then it says it's y equals 1. So go to y equals 1. That's that blue dot right there. You need a line that intersects that. So now those are the asymptotes. Okay? One was the 0. One was the y-intercept, right? I've color-coded it. So look, purple with purple and so on and so forth. Okay. Now, okay, hang on. Now, go ahead and take out your calculators. All right, before you plug anything in, take a look. This is the most important thing I'm going to say to you today. When you're plugging in a rational function to graph, you have to use parentheses. So right here, you have to put parentheses here and here. So why don't we go ahead and do that? In parentheses, we have x plus 2, close parentheses, divided by, in parentheses, x minus 1. Enter. Okay, that's what that looks like. All right. Now, I've asked for some points here. Okay. So let's go to control table. Control T. Do you see how at x equals 1, it's undefined? Because what was x equals 1? The vertical asymptote, that red asymptote. So you can never use that in your table. Now, what we're going to do, can everybody look up here for a minute? Look at the, look at this, right? The vertical asymptote is right there at x equals 1. I want to make sure to pick at least 2 points from the right of that and 2 points from the left of that. So I'm going to pick 2 and 3 here. 2 and 3. Well, yeah, like after it, right? And then to the right, I want to pick, 0 and -1. Okay, so here, -1 is -0.5. 0 is -2. I'm just reading them off the table. 3 is 2.5. 2 is 4. Okay, let's go ahead and graph this. So at 2, it's 4. At 3, it's 2.5. At 0, it's -2. I already have that. At -1, it's -0.5. Okay. So now, your graph Okay, so now you have to give it the shape over there, right? So your graph must follow the asymptotes, okay? So here it's got to follow that vertical asymptote, come down, and then follow that horizontal asymptote. Down here, it's got to follow the horizontal asymptote, pass through the points, and then follow the vertical asymptote. Okay? So, to recap, we did things without the calculator first, right? We found all of this information first, zeros. Oops. How did it go away? All right, we found zeros. We found y-intercept, vertical asymptote, horizontal asymptote. We did all that first, then I put it in the graph. Okay? All right, let's do another one. Okay, put your calculators down. Let's do this one. Zeros. I set the numerator equal to 0. X equals 1. If you want, you can plug them into the graph as you go, right? So the 0 is x equals 1. There is a 0 at x equals 1 right there. Okay, y-intercept. It's going to be y equals 0 minus 1 over 0 squared. Does that work? Can you have a 0 in the denominator? No. So then there is none. Okay? And that's okay. Say none, but don't leave it blank. Okay? If there is none, say none. Yeah. It's none because there is a 0 in the denominator. The denominator is 0. Okay. For the vertical asymptote, I take the denominator, set it equal to 0. So x is how much? 0. You take the square root of both sides, right? So x is 0. Let me actually do that in blue. So x is 0. Okay, so you go to x is 0 and then you do a vertical asymptote there. Okay? Horizontal asymptote. I have to compare the degree in the top with the degree in the bottom. Exponent of 1 on top, 2 on the bottom. If you have a lower exponent on top, what's the horizontal asymptote? 0. Okay, y equals 0. It's the rule. Look, right here. If the degree of the top is less than the degree of the bottom, the horizontal asymptote is y equals 0. Because it's x1 over x squared. Okay? Okay. So, I've done all that. I've plotted all of it on my graph. Now, I'm going to go and plot this. Okay, so let's go here. So I go to tab, up. So this is going to be, I can just edit it. X minus 1 over x squared. Okay? You see how that looks? Okay, now take a look. Let's decide what points we're going to pick. My vertical asymptote, that blue line, is at x equals 0. Okay, so I want 2 points from the left, 2 points from the right. To the left, I have -2 and -1. And then I have 1 and 2. So let's do Control T. You could do whatever your heart desires. Okay, so -2 is -0.75. -1 is -2. 1 is 0. And what's 2? 0.25. Okay, so 2 is 0.25. Super close over there. -1 is -2. -2 is -0.75. Okay, now I go over this way and down. And take a look at how this looks over here. Okay, look, this goes up above here, and then it kind of like slopes back down and follows that asymptote. So it's going to come up. If you want to find more points along the way, you absolutely can. So it kind of like slopes back down and this. Now look, what was the zeros of this function? When we found the zeros, what did we find? Guys, what was the zero of this function? X equals 1. What does it mean to be a 0? That's the x-intercept. That's where the graph crosses the x-axis, right? Right there. That's where it crosses the x-axis. Are there any other zeros in this function? No. That means it only hits the x-axis once. So when it goes up, it can't cross the x-axis anymore. And then so it just like comes very close to that line. Okay. Any questions? Okay, now look. Okay, let's do another one. Okay, the zeros. For the zeros, I set the numerator equal to 0. Is that possible? No, so none. The y-intercept. Y equals 5 over 0 minus 1, 0 minus 4. 5 over negative 1 times negative 4. So that's 5 over 4. Okay. Okay. Vertical asymptote. What do I set equal to 0? The denominator, x minus 1, x minus 4 equal to 0. Look at that. It's already like factored for you. X equals 1 and positive 4. Okay, so I go to x equals 1. And I go to x equals 4. There's 2. Yeah. You set the denominator equal to 0 and you have to solve it. Okay? Okay. Now for the horizontal asymptote. This one is a little bit involved. It's a little bit tricky. So, take a look. What is the exponent in the numerator? There isn't one, which means it's 0. Okay? Because this was really x to the 0. Okay? That's why it's not there, right? So it's 0. Okay. So by default, it's going to have a higher exponent in the denominator, right? So what will be the y equals 0 will be the horizontal asymptote. Okay. Now I want to say something else. The degree in the denominator, right? What do you think is the degree in the denominator? Not 1. Okay. It's 2. But why is it 2? Because when you multiply it out, right, all of these have, like, when you this is factored over here. But when you multiply this out, it'll be x squared plus blah, blah, blah. That's why it's 2. Okay? All right. You do, because if it was something else in the numerator, then you would have to compare it. So yes, you absolutely do. Yes. Yes. I will never give you useless information. Okay. Let's graph this. Now it's going to be a little bit tricky because how many regions do we have here? How many? 3 regions. So you know how we were picking points like, from the left, from the right, and so on? Well, now I have 2 asymptotes to pick from the left and from the right. So let's see what we're going to do here. Why don't we just graph this first? So I'm going to do doc B and just start fresh. Tab. Here. Okay. So what is our lovely function here? 5 over, in parentheses, look, we have to double the parentheses here. I open up a parenthesis, then in another one, I go x minus 1, close, and then another one, x minus 4. Okay. Go ahead and graph that. So at the very left, right, I have x equals 0 and x equals negative 1. So let's do -1 and 0. Control T. Okay. Now, in the middle section, why don't we do 2 and 3? That's all we can do. Yeah. So those are -2.5 each. They're both -2.5. And then let's go to the other side, 5 and 6, and do 1.25.5. Okay. Well, because it goes up and then back down. Okay, so -1 is 0.5. 0 is 1.25. 2 and 3 is -2.5. Okay. And then 1.25 and 0.5. 1.25 and 0.5. Okay. So we go ahead and graph this. So here I got this goes up here and comes back down and there. Okay? Picture in the graph. Okay, so when we talk about vertical asymptotes, not the horizontal ones, when we talk about the vertical asymptotes are discontinuities in the graph. Okay, vertical asymptotes are discontinuities in the graph. And you can see here, like if you have your pencil on the graph, right, and you're tracing it, when you get to the first red vertical asymptote, you have to take your pencil off and then continue, right? That is a discontinuity. The graph is literally broken up. It's discontinuous. Now, there are different types of discontinuities in the graph. The vertical asymptote is by far the biggest one of them. It is not only a discontinuity, it is called an infinite discontinuity. You really cannot get around it. Like, it is just there. You can't fix it. You can't patch it up. It's just there. There are other types of discontinuities. One in particular, which could be a removable discontinuity, right? You also have a removable discontinuity. That looks like a puncture in the graph, just a tiny little puncture, basically not even visible to the naked eye, right? But it's still there. So that happens when the numerator and the denominator have a common factor and you can cancel them out, okay? So take a look here. All of the ones that we've been doing so far, I haven't made you factor anything because there wasn't really much to factor. This one here, however, before you do anything, you have to factor. So here, the x squared minus 4 becomes x minus 2, x plus 2, over x minus 2. What happens now? It just becomes x plus 2. So let's go to the zeros now. For the zeros, you have to look at the final function. If there is a numerator, you set it equal to 0. So x plus 2 equal to 0, x equals -2. For the y-intercept, also the final function, y equals 0 plus 2, y equals 2. Okay? So far I have this and I have this. Okay. Vertical asymptote. Because for the y-intercept, we plug in 0 for x, remember? Okay, so for the vertical asymptote, we have to set the denominator equal to 0. Is there a denominator that has not canceled? No. So we say none. Okay, hang on. Let me finish. For the vertical asymptote, you only set denominators equal to 0 if they have not canceled. Okay? So there is no denominator that has not canceled. So in the ones that we were doing before, this x squared here never canceled. So we set it equal to 0. Right? This x minus 1 here never canceled. So we set it equal to 0. Okay? Now, horizontal asymptote. Okay, look at the final one. Is there even anything to deal with there? Like, is there even it's not even a fraction, right? So there is none. Okay? Because what do you do for the horizontal asymptote? You set the numerator from the top, the degree, you compare the degree in the top, the degree in the bottom. Well, there is no degree in top and bottom. Everything just went away, right? You don't even have a fraction anymore. Okay, the removable discontinuity, this is the one now. The removable discontinuity, you set denominator that canceled equal to 0. Which denominator canceled? X minus 2 canceled. So you set it equal to 0, and it's at x equals 2. Okay, so there are no horizontal asymptotes. There are no vertical asymptotes. There is really nothing to do here. So why don't we go ahead and, by the way, what did this graph reduce to? Y equals what? What did this function reduce to? Y equals x plus 2. How do you graph y equals x plus 2? What does it look like? It looks like a line. So here, why don't we graph the original function. Doc B. Okay, let's graph the original function. In parentheses, x squared minus 4 divided by x minus 2. Okay, you get a line. Okay, so now let's do this. Okay, so here I have the 0 and I have the y-intercept. Okay, let's go ahead and do control table. Okay, so look at that. At x equals 2, it's undefined, right? What would it have been? So what do you think, like, if this wasn't a removable discontinuity, if you put 2 in there, what would the y have been? If you put 2 in here, so if you graph this basically at 2, what would it have been? 4, right? Like, look at this function. If you put x equals 2 in there, wouldn't that give you a 4? So at 2 and 4, there is a little puncture. You have to draw that and then continue this. Okay? Yeah. Which part? Where to put the circle? Okay. Do you see how? Okay, so let's forget about that. So let's just graph this line. Okay, but you can't do that because at x equals 2, there is a discontinuity. It can't be a smooth graph at x equals 2. No. At x equals 2, where is the point on the graph at x equals 2? Right there. Right? 2 comma 4. At x equals 2, where is the y value? You see how it's at 4? Okay. So somewhere at x equals 2, there is a puncture in the graph. But how do we know where that puncture is? Is it here? Is it here? Is it here? Is it here? We don't know. How would we ever know? Okay, right. But how would you know, like, before you were graphing? Like, if, yes, so that gives you x equals 2. But how do you know what the y value is? Okay, yes, it's where it hits the line, but if you want to do it without graphing, you also take this and plug it in here. 2 plus 2 is 4. So it's at x equals 2, y equals 4. That's what I was trying to say. So right here, I can't. Okay. So in reality, like as you can see here, if you can look on the graph, right? Let me take this off. So when you look at the graph, do you see a hole in there? You don't, because it's so tiny, right? However, that's how it is in real life, because it's only at x equals 2. At x equals 1.99999, it doesn't exist. Or at 2.00001, it doesn't exist. So you can't really see it in actual life. However, on the graphs, you have to show, a little circle over there, a little open circle. Okay. Also, some students do this, like they'll graph the line, and then on top of it, they just do a circle. You can't do that either. There cannot be anything in that circle. It just has to be a blank circle. Okay. Okay. Right. Okay, so the zeros, it'll be x equals what? 4. What would the y-intercept be? No. 4 over 3. Good. You set, okay. What's vertical asymptote? No, you go to the final function, you put 0 in here. 0 minus 4, 0 minus 3. You get 4 over 3. Even if you went to the original, you would get the same answer. It's magical that way. What's the vertical asymptote? Because we've been doing that every single time to get the y. No, you plug in 0. Look at the previous ones we did. Okay, what's the horizontal asymptote? Y equals what? 1. Where is there a removable discontinuity? You set this equal to 0. X equals -2. Okay? The